This is the Artificial Social Intelligence for Successful Teams project, or ASIST for short. A building is structurally damaged after an unspecified incident. Injured victims are trapped and need assistance. In this simulated environment, the team has to locate, stabilize, and transport both regular and critical victims to safe zones according to their injury type. The team consists of 3 human players along with the advisor. Each player has unique roles, knowledge, and skills. The engineer removes rubble and knows the location of hazardous rooms, but moves slowly. The medic diagnoses and stabilizes victims with a normal walking pace. The transporter can detect victims and moves the fastest. All of the players can transport stabilized victims. Their goal is to work together to search for and rescue as many victims as possible. The advisor can infer the mental states of human team members, predict their next actions, and intervene with advice to improve their teamwork. To develop the best ASI advisor, we created 8 different conditions. The human advisor can use voice to communicate, while the ASI uses text chat in Minecraft. Each quadrant here represents one of the computer interfaces. The top left is the administrator's top-down view of the building, the upper right is the medic in red, bottom left is transporter in green, and bottom right is engineer in blue. They're equipped with a set of marker blocks on their toolbar and have a real-time dynamic map showing their position as well as marker placements. In addition, unique information on the bottom of their client map can help them find the rooms that have the highest concentration of critically injured victims. Here's an example of the human advisor giving advice.
This is your advisor. There seems to be miscommunication. Which C zone needs to be cleared?
Oh, yes, sorry, South Zone C.
And here's an example of the ASI advisor giving advice.
Let's see.
We ran 113 valid teams involving 339 participants nationwide. Participants joined remotely through Parsec to play on our lab computers and used Zoom to verbally communicate with their teammates. This study resulted in 1 terabyte of data accessible on the ASU Library Dataverse. The testbed itself is open source and on GitLab. Data analysis is ongoing. Here's a list of some of the measures we used in this study. Here's an example of IHMC using a subject matter expert rating process to analyze good and bad teamwork. The visualization depicts the players' individual and joint actions. And University of Central Florida analyzed how team profiles predict team performance. We would like to acknowledge the program sponsor DARPA, as well as all of the performers who contributed to this project. Thank you.